In our last video, we talked about ground state and excited state and said that when an electron gains energy, it bumps out to a higher energy level, and that's called the excited state. The excited state is unstable. It won't stay that way long, so the electron will move back. When it moves back, it releases energy, often in the form of light. And that is how fireworks get their colors. So we're going to talk a little bit about that in this video. So quantum theory says that electrons can only absorb and also release specific amounts of energy called quanta. And these would correspond to the difference between energy levels. So for example, let's say we have aluminum. And aluminum's electron configuration is in the ground state 283. So that means we have the nucleus, which I'm just going to draw as N. And then it would have 3 electron shells. 1, 2, 3. 2 electrons in the first shell, 8 in the second, 3 in the third. Let's also draw in the empty fourth level. Okay, and let's just give easy numbers so that we have an easy example to work with. Easy energy amounts to each one of these shells. So let's say the first shell is equivalent to 50 kilojoules of energy. And let's say the second shell is equivalent to 75 kilojoules of energy. Let's say the third shell is 150 kilojoules because each shell has a specific amount of energy associated with it. And let's say the fourth shell is equivalent to 200 kilojoules of energy, just so that we have some easy numbers to work with. If an electron is going to move from the third to the fourth shell, it would need to absorb 50 kilojoules of energy, because this one's 150, that's 200. Then on the way back, it will also release 50 kilojoules of energy. So that's really all that this is saying here, is the electrons are going to absorb and release a specific amount of energy, and that's going to be equal to the difference between the energy levels. And that amount's all going to be absorbed or released at once. And then the last thing's just a vocabulary word. A quantum of radiation is called a photon. So when the electrons return to the ground state, they will release energy depending upon the wavelength that's associated with that energy. We will get different colors of light. Every element is going to have different amounts between their energy levels, so they will all absorb and release specific amounts of energy, which then would have different wavelengths and produce different colors. Therefore, they can be used for identification. So for example, potassium makes a nice, pretty light purple color, and sodium burns with an orange flame. So you will get different colors for different elements, therefore it can be used for identification. And this is how fireworks get their colors. So different salts are put into the firework. When the firework explodes, that provides a lot of energy. That energy pushes an electron out to the excited state, falls back, releasing energy in the form of light. And you get the different colors for the different substances that have been added. Another thing that goes along with this is the spectra of an element. So you looked at these in earth science, so they should look somewhat familiar. So different elements are going to produce different spectras. So if we take a look at light with a spectroscope, it breaks it up into these different lines that are called spectral lines. And just like every element, produces a different color. Every element has a unique spectra, so this can be used for identification. This is a little bit more accurate than just the color because there will be some substances that burn similar colors, whereas their spectra is going to be a little bit different. But obviously this is a little bit harder to observe than just observing the color. So here is an old Regents question that is using spectras for analysis. So we have an unknown. So here's the spectra of our unknown. And the unknown contains two different elements. So if we want to figure out what two elements are in our unknown, we literally just match up the lines. So we have a line here that came from helium, and all of helium's lines, all of helium's spectral lines should be present. But notice we also have some lines that are unaccounted for. So in addition to helium, we would also have a different element present. So we also have these lines right here, and those look like they come from hydrogen, and then this line too is from hydrogen. And that's how we would know that there was only two of them, because now we've accounted for all of the lines. And then of course the question also said two. Okay, then our second question, explain how a bright line spectrum is produced in terms of excited state, energy transition, so gaining and releasing energy, and ground state. So we have to use all of those words and all of those concepts in our explanation. So take a second to think of your answer. You can pause the video. So the spectra is produced when an electron or electrons move from the excited state back to the ground state, releasing energy in the form of light. If you happen to look at that light using a spectroscope, then you get the colored bands, the spectral lines, and you get the spectra.